already. So the borehole is here and is in operation. The control is inside here and it will indicate you. You can see where our colleagues are. That's where the control panel is. That is controlling this borehole. We have 17 of them, and this particular plant itself, I will show you later, we are controlling 17, and we are even controlling the remote control.
How many taps can a borehole be attached to?
Okay, interesting, lot. But what we're saying, average boreholes that we have here, we are giving like 75,000 liters per hour. Yes, every borehole. Most of them are a little bit, some are slightly less, but we take average of 75,000, 77. Some of them are more than that because we can get as much as 103 cubic meters per hour. Depending on the amount of people living in the area, based on that, that's how you design the amount of water required for the area. Taps can be as many, but maybe people are not using them at the same time. You can have 10 taps and maybe one will be operating at a time. So what we look at is the amount of people living in a particular area, then their water needs is designed based on those. We need to know the amount of customers you have in a particular area and then be able to design something that will be able to solve the water requirements of those people.
What is it like to control water from here, from the borehole?
Yeah, what we do, like I said earlier, inside the borehole, we have electromechanical equipment inside we call a pump. So inside that pump is being driven by electrical power. So this power that is what is being stationed here. You can see the control box. It shows you the amount of current, the indicators to show the conditions of the borehole. But also, these particular boreholes can be controlled, remote control, and can be controlled manually. Some of them are very far from this plant. I can tell you some are like 20, 25 kilometers away from where we are standing. And we are using...
Yes, you control them from here.
Operate, we can see the amount of flow, the amount of water coming in and out as well.
Interesting.
Yes. So
from here now, where do we move next?
What happens is that from the borehole, we're sending this water into the aeration. What the purpose of the aerator is that we need to keep the quality of water in terms of processing. Here is a processing plant. So what we look at first, we have to look at the quality of water that we are giving to our customer. When the water is coming out of the borehole, there are requirements that WHO standard that he sets that water must reach these standards before people can drink.
You talk about aeration first. When we move from here, we're going to the aeration department. For some of us that don't know how water is processed, what's the term aeration mean?
Thank you. What we're trying to do with aeration is that we're trying to improve the pH content of the water. If you like, we make it more soft and make it more drinkable, like to drink. Because here, the quality of water in Gambia, we have always been proud that quality is always good. But to meet the required standards of WHO, when we are coming from our borehole, we get standard sets of pH of 6.1. And the WHO standard is from 6.5 to 8.5. So we use the aeration to build up to that level. We have another chemical that we can apply again to improve the pH content of the water. Because we do two things, it's the aeration and also disinfection. We use chlorine to disinfect the water. So I will show you also in the process where we do that process of treating the water for disinfection. In case of transporting, because the water is coming raw from the boreholes. When from the boreholes, you can see from this borehole, it's joining, there's a line, there's a pipeline here. Yes. All the pipes are linked from the borehole, from the field. They come through here and enter through that wall. That's where this one also is connected. Then it goes through that line to the aeration unit where we're going.
This is the aeration unit?
Yes. Thank you. Rohi, what we are doing here, like I said earlier, that's where we are improving the pH content of the water. So raw water from the boreholes is coming through this line. You see this 1, 2, 3, 4 pipe connections. That's where they are all taking. From there, they are going through a nozzle. In that nozzle, the water is being poured through these grills. From the grills, you can see now there's a space in between that allows more particles of air to go into and that improves the pH content of the water. From the aeration unit, then your water will all go down, and there's a collection point there. Like I say, we improve the pH content, makes the water very nice and soft to be able to drink enough.
Water gets very nice and soft. Look at the way it has 4 layers.
Yes. Exactly.
Is there anything that's sifted in the water?
It's not actually sifting it. What it's doing is just allowing that slow movement. Because now you see, when you are seeing on top, if you could see, it's coming with real pressure. So when it shoots on the ground, there is on the top one, so it's going to go through it. Because we want it to have a slow movement, and that space, we have air breaking it. and allowing those things to interact with the air.
So each borehole has one aeration unit, or they have more than one?
No, of course, if you see here, you're talking about 8. An actual amount of boreholes coming here is 17. So they are all linked into one big pipe. So from that pipe, that's where this feeding into these aerator units. They are all connected. As they are coming, all the waters that are coming from these 17 boreholes are all mixed along the way, coming to the treatment plant. This is a very big treatment plant because we're receiving like 300 liters per second of water. So from here, after the aeration, all the water is now collected back, go into these pipes, and then, yeah, this is where, from the aeration, because they are divided into units. This one unit, 1, 2, 3, 4 units.
4 units in this plant?
Yes, exactly. So then from here, all the water falling from this particular unit is being collected through this. The water is already safe, obviously. And
make it more purified.
Exactly. From our borehole, you can open the tap and drink. It's safe to drink. Actually, we just want to make sure that it is as above standard, not below standard in any way. So that is why we have to pass all these processes. But in Gambia, I always say this, we are proud that we have a very good quality of water for now, which I always advise that we should protect, we should not abuse, because it is good and we don't just take care of it. So it's a responsibility on all of us to make sure we keep it as good as it is.
You talk about protection of the water. When you're talking about protection, how can Gambians protect this water?
Exactly, very important. What normally the most dangerous part is that how do we contaminate the aquifer? The aquifer is where we are tapping our source, where we are collecting the water from. If you drill like a well and later you change this well, you want to abandon it, never use it as a toilet. Because if you do that, you are contaminating the aquifer. Because the well already is where the source is. So if you pour anything there, it's going straight to the supply. And always you will find a NAWEC always try to drill boreholes away from settlement. Because all what we are trying to do still now, we are trying to protect our source. But normally, as you move away from people and drill a borehole, people tend to go and settle around the borehole because they think it's development. But what I will advise to those people, then they don't need to drill local latrines that are very deep. It's not very shallow, very, very shallow.
Going back to the process, now that we've seen where the pipes are